Welcome to day two of the 2025 AGTA American Gem Trade Association's Inspire Seminar Series, sponsored by the AGS, the American Gem Society. Introduction to new platinum and how the industry is responding. On our stage this afternoon is Josh Helmich of the Helmich Luxury Group. Josh is the jewelry industry's senior professional, a third-generation jewelry entrepreneur, visionary, and consultant. Josh has extensive expertise in strategic business development, manufacturing, and technology implementation within the global jewelry supply chain. Founded in 2018, the Helmich Luxury Group combines the knowledge and experience Josh has garnered over 2 decades in the jewelry industry in wholesale and retail jewelry trade, manufacturing, technology, and design. Josh works across the United States, Asia, UK, and Europe with clients such as Anglo American, Platinum Guild International, and various other luxury jewelry brands across the globe for a variety of projects, including manufacturing process technologies, sustainability, metallurgy, supply chain, traceability, social responsibility within the industry. Please join me in welcoming Josh Helmich.
Thank you, Gary. Thank you, everybody. Pleasure to be back in Tucson. My daughter's here today, which is very cool. I remember coming as a 5-year-old, 6-year-old to the show, so it's nice to kind of be that next generation coming through. And thank you, Gary, for the introduction. I think he spelled out pretty much everything that I do. I do have to say I am missing my counterpart here. So generally, Kevin Reilly from Platinum Guild co-presents with me, but Kevin had a major scheduling issue, so I'll be presenting some of the Platinum Guild information and running it through into the new platinum alloy that's been launched. So let's get started. So today we're going to go over a couple initial things. Why do people prefer platinum? Some of the myths, misconceptions, challenges of working with platinum, the importance of proper alloy usage, and I'm going to introduce Inoveo. It's a game-changer new platinum alloy that is now on the shelves. So some of this you guys may be very aware of. This is, I'm going to say, Platinum 101, kind of from PGI. So this is why people prefer platinum. You know, you've heard the pure, rare, it's enduring, it feels significant, it elicits an emotional response. It is the real white metal out in the marketplace, and it is the most secure setting for diamonds and colored gemstones. Just some facts. Most people know platinum jewelry in the U.S. is typically 95% pure. This has not always been the case. It used to be 90%, 90 and 10. Other parts of the globe, it does vary. 95 is kind of the standard bearer that has been set, but you go to places like Japan and they're still running platinum 850, platinum 900 for certain types of chain production. Most people are very aware 14K is 58.5% gold, 18K is 75%, and platinum jewelry makes itself, it's very hypoallergenic, so it's very sensitive to the skin. Platinum is extremely rare. It's 30 times rarer than gold, only produce about 88 tons into jewelry per year compared to 2,700 tons of gold. 50% of the platinum mined and goes into other industries, catalytic converters, cancer treatment, things of that nature. Food preservation is something new. It hasn't been launched here in the US, but they have developed where platinum is actually able to preserve food in refrigerators. Now it's been launched in Asia, so your food can last up to, I think it's about 60 to 70% longer than it otherwise would. So it's kind of nice, especially in very humid climates where food can go bad quite quickly. Platinum is valuable. So one of the things, platinum is, it's very dense. You know, when it's scratched, it's different than gold. You know, gold, as you scratch it, kind of wears away, flakes away. Platinum moves more like butter. It doesn't flake away, you're just displacing the metal. Over time, typically platinum reflects kind of a satin finish. It's been referred to as a patina. I will say, you know, in terms of patina, in some aspects of the world, it is more sought after than others. So I do find in places like America, people don't really want a patina. They want their jewelry to stay shiny and bright. You get into the Japan market, the patina is actually very sought after. It lasts for generations. Everyone here has been in the jewelry industry a long time. You know, you see those pieces, those platinum pieces from the 20s, 30s, 40s. They're still in great condition. So it is one of the densest of the precious metals. It's actually one of the most dense metals on the planet. 60% heavier than 14K, 40% heavier than 18K. It does feel distinctively different. You know, if you ever put a piece of platinum in your hand, same platinum ring, same gold ring, you can feel the difference. Little fun fact, 6-inch cube of platinum weighs 165 pounds. So this is actually part of a study that Platinum Guild did a few years back. And so nearly 70% of American consumers actually prefer platinum for their engagement ring. However, I do know that only about 15% translates into actual sales of platinum. That's a story on itself. Some of that is down to the retailers, what they stock, what's available, what sales associates actually know about platinum compared to gold. But in this wide-ranging survey, platinum does sit at the top, specifically for white metals, of course. A lot of consumers, as you guys probably know, anyone here who's in the trade, you know, they still aren't aware that white gold doesn't actually come out of the ground white. It actually requires other things to be alloyed with it. And then, of course, rhodium plated. Platinum is naturally white, always remains white. And a lot of consumers, when they discover white gold, it's you know, one of their common complaints, having to go back and have it re-rhodium plated constantly. And depending on how hard they are on their jewelry, which we know, and I will say the American market, and I traveled the globe quite a bit, the American consumers are harder on their jewelry than anywhere else that I travel across the globe. So it is nice, I think, for the retailer to be able to get them back in, to re-rhodium plate, to get them back in the store. But anyone who's been in the trade a long time knows that there's a lot of complaints when their white gold starts turning yellowish, especially when it's not alloyed with palladium, which is not that common in the US. Platinum is corrosion resistant, dense, durable. It doesn't have metal memory unlike gold. So when you impact the prongs on platinum, it typically will just smash down a little bit, where gold can get brittle, can break, things of that nature. There is nothing that holds a diamond or gemstone more securely than platinum. Now, this is something that I'll say, PGI, if Kevin was here, he'll tell you, you know, this is something PGI promoted for a long time. You know, how secure is it? But no one had ever really done a deep, deep study into prove that. So there was a 4-year study. This wrapped up a few years ago. Some of you may have seen some presentations on this. This was PGI, FEM out of Germany, and also Techform Casting, Teresa Freya up in Portland, probably one of the top platinum casters for sure in the United States, was also part of this study. And it's very wide-ranging, and if anyone wants to read the whole study, I'm happy to get them the info after. It's about a 40, 50-page study over 4 years. They actually tested platinum alloys from around the globe. Corrosion resistance, wear resistance, how secure do they hold the gemstone, performing against white gold alloys. So I will jump into just some of the highlights. So this right here So what they did for the wear resistance is this entire ring was catted, and the stone was also platinum. So instead of putting a live diamond in there or a CZ, they did the whole thing in platinum, and they ran through abrasion test, corrosion test, polishing testing. Testing time was 252 hours, different types of abrasion. And one of the conclusions that came out of it was despite the significant lower hardness, so hardness does not always translate into durability when it comes to metals. So for instance, white golds in general tend to be about 190, 200, 210 on the Vickers hardness scale. Most of your platinum alloys, depending on what part of the globe, but here in the US are around 125, 130. So this is very interesting. So you'll see, here's the charts. And this is how much material actually wore away over 252 hours. So you've got your 18K nickel white gold, palladium white gold, your 14K nickel and palladium whites, and you've got platinum ruthenium and platinum iridium on here. Now I will say if you go in depth with the full paper, there are various other platinum alloys that are on here, but we've shrunk it down for presentation purposes. Platinum ruthenium is the most durable of all the platinum alloys on the global market today. That's why companies like Tiffany & Co., that's what they use, 95.5 PT ruthenium. So you can see over time, it's pretty drastic. So this is to represent what the end consumer goes through. The end consumer beats their rings up in the jewelry industry. How does it last after a year, 2 years, 5 years? So this translates to the security of the gemstone. The emerald, the diamond, how well does it secure, how much material wears away over time. So as you can see, it's quite a significant difference. This was over the 800 hours, and obviously over time, as any of you that are obviously see this on the retail end, you get consumers that come in and their gold is worn down to nothing many times over. So many of this you guys know, but Platinum Alloys 101, there's always a mixture. Precious metal in its pure form, platinum or gold, is extremely soft. It's typically not used for finished jewelry in most parts of the globe. I won't say, that's 100% because when I traveled to, places like Japan, they actually do sell PT 999 jewelry in some form, 24K. While it's not so popular in the US, you get into China. I just got back from India yesterday. They are popular over there, but they're typically very, very heavy pieces. But it's not great for daily wear and tear. Typically, the 24K in those markets is bought for investment purposes, things of that nature. So now this is something that, doing these talks, you get people, and I always ask, have you ever seen a platinum ring do this? And I think anyone in the trade has seen platinum rings that have bent, and unfortunately, it's given platinum a little bit of a bad rap, I will say, especially at the counter, because you have a lot of sales associates who maybe are not fully aware of even what an alloy is, surprisingly enough. They're not aware that there's different platinum alloys or even different white gold alloys and how they perform. So this is something that, and I will say the past couple of years, I've spent a lot of time in the LA market. This is something, a lot of production that comes out of Los Angeles. You see this happen to the platinum products that are coming out of LA, or you were seeing it, I will say. We've made quite a bit of headway in curbing that. So the one thing that I want to point out, it really has nothing to do with the platinum. It has to do with the other 5% used in creating the alloy from manufacturing. Here's some other examples. You'll get customers who, even pick up a suitcase and their platinum ring bends. And so consequently, they think platinum is just a terrible metal to have, and they potentially might never buy it again. So these are examples of 95.5 PT iridium. So this is a little breakdown. These are the 4 most common platinum alloys in the US market. So I'm going to actually start with platinum iridium, 9010. So that is what was made famous by Cartier and all the companies who started building platinum in the 30s and 40s. That's what was used. That was common. But back then, everything was hand fabricated. So you got a work hardening curve. You hardened it. They're building it. They're drawing wire down, drawing sheet down. And so for decades and decades, that was common. That's why those estate pieces are still in very good shape that you see on the secondhand market these days. When platinum really started to pick up steam, I'd say in the US, especially in the 80s and early 90s, when PGI really pushed into the market and casting started to become the prevalent way of manufacturing versus hand fabrication. I mean, I have a lot of respect for the hand fabrication. It's a little bit of a lost art out there. It's very time consuming, and for production, it's really not cost effective, and it hasn't been cost effective in a long time. So initially out of the gate, what happened was with the casting, they went into 95.5 PT iridium. One of the big differences is, so when you get to the work hardening of a 9010, it's about 130 Vickers. PT 950 iridium is about 90 Vickers. So it's something that it's very easy to cast with. This is something that's been a problem in the Los Angeles market. It's simple to cast, it's got low porosity. Unfortunately, everyone else down the line, specifically the end consumers, have a terrible experience with this. And people aren't aware about that 5% that goes into it. Now, I've given talks to the West Coast Diamond Club and various other, and a lot of companies aren't even aware that there's different platinum alloys on the market and that they can order different things. You know, probably the 2 at the top, the PT Ru and PT Cobalt, those are kind of the 2 standard bearers, I would say, for the US market. PT Cobalt is slightly magnetic. It does have a slight oxidation, so not everybody likes to use it, but it casts very well. PT Ru, it's great fabrication. It's a little bit more challenging to cast, so it requires some extra spruing, things of that nature. But again, if you look at the big luxury houses, that is what they use. But you know, one of my main points here is what's in the alloy is very important. It's important for the manufacturer to know, important for the retailer. But the U.S. market is extremely fragmented compared to other markets that I travel around the globe. There's a lot of contract casting that goes on. Certain contract casters I have spoken with, I will ask them why they're even offering PT 950 iridium. And they say, well, nobody asked for anything different. And I said, but you're giving them a terrible product. And then consequently, the end consumer is getting a bad product. And so these are things I think as people become more aware. Platinum was really exploded in the 90s and early 2000s in the US market. But it started to see a pretty big downturn, especially 2006 to 2008-9. Platinum crested up around 2,000 an ounce. Gold was still down in the 600s, 700s. And so platinum took kind of a dip. And it has recovered quite significantly. Now the prices are completely flipped. And so we've seen double the amount of platinum into the US jewelry market just in 3 years. So there's an opportunity, especially on the retail end and the manufacturing end, to grab better margin and offset with the white gold. But it is very important that you understand the different alloys, what you're getting, what you're selling your customer, what you're manufacturing with. So with all that being said, I'm going to introduce this new alloy, Inoveo. It is on the market. So a little bit of background on this. This has been almost 5 years in the works. A little bit of the story behind the creation of it. So Initially, this started in 2019. Platinum Guild had mentioned to its sponsors, specifically Anglo American being the largest sponsor, that was there a way to create a new alloy? Something that could have the benefits of casting and fabrication. There has been a lot of platinum alloys created over the last 25 years. A lot of them, basically, I call them lab creations. You can write some great papers about them, Santa Fe Symposium, Johnson Matthey, so on and so forth, but you don't see much of that stuff coming to market. So this was tasked, actually, then Anglo put this together, and they wanted to listen to the suppliers, the casters, manufacturers, designers, retailers, and consumers. What was important to everybody along the value chain? So some of the issues that the manufacturer and retailer, have discouraged working with platinum. Casting's tough. It requires additional equipment. Porosity issues, regardless if you cast in-house or you pay contract casters. It's harder to polish. It's gummy. Tool wear, soldering, perception. This is a big one. Not as durable as white gold. Some of that goes to the improper alloys that have been used. But again, not a lot of people, even within this industry, know. Bad consumer experience. Lack of skills. Anyone in here who's a jeweler knows that, becoming a platinum smith is kind of another step up from a goldsmith. Requires a couple additional skill sets and also the ability to work with it. If you're not able to work with it, you can't become an expert at it. And, the cost associated, specifically with platinum and the equipment used. So, there's always been trade-offs. You can make a harder platinum, but it's brittle and not malleable. Things of that nature. You have little room for errors. You have a narrow operating window when it comes to casting platinum versus gold. Gold's much more forgiving. The amount of labor, again, platinum smiths, requires a few more skills. So it's also limited. The consumers, on the other hand, they want long-lasting whiteness and brightness. I always say the consumers, they want a chrome bumper on their hand as much as possible. And they want durability, wear resistance. Those in the retail trade in this room know that consumers do not come in and get their stuff checked regularly. There is a major problem across the jewelry spectrum. They'll bring rings in, and it's literally been ran over by a car, but they will tell you, I never wear my ring. It just sits on the bedside. So I think most of us have all seen those stories. Platinum has also been a little more difficult to do designs across the spectrum. And there's been a missed opportunity. And so these were some of the main points taken from this value chain in terms of why creating something new. So there had been very little development in 15 to 20 years within platinum. In the 90s, there was quite a bit of development. You had the Kretschmer companies and Michael Bondanza. There was a lot of people pushing a lot of platinum out there, a lot of new stuff coming onto the market. The consumers have had a little bit of a negative impression about platinum. And to resolve this, Anglo collaborated with a company named Alloyd. And Alloyd is out of Oxford. It was a spin-off from the university. And they're a materials design developer, and they wanted to tweak that 5% mixture to develop something that's game-changing, new alloy. So this project I've actually been on since just about the beginning. And it was something that Anglo came to me and said, we're developing this. And one of the first things I told them, I said, this sounds great, but it cannot just perform in a lab. It has to be able to perform on the manufacturing floor. Big manufacturer, small manufacturer, repair jeweler, everything across the line. Because if it doesn't do that in a controlled environment, like in the lab, you can get a lot of things to perform. But when you're actually on the ground, it's difficult. There's deadlines to meet. There's production issues. Everyone's running different equipment, things of that nature. So this was actually launched at JCK last year. We did about 3 years of testing. Started in the lab. It went to small-scale jewelry floor testing, which I co-wrote all the tests. I oversaw all the testing. I wanted to see tests on everything. There's a whole different presentation on everything that was tested, from pave setting, laser, soldering, soldering with solders off the shelf, lasering with the wrong platinum alloys, because let's face it, you get out into the marketplace and that is what happens. So wanted to expand something that's brighter, more versatile, and wear resistant. Expanded the capabilities, and it's an industry first. And it really is the first, I would say, to offer all the benefits of platinum with the ease of white gold. So going back a little bit, how this was created with this company, Alloyed, how precious metal alloys have been created throughout decades and decades is basically trial and error. They take things that have been done in the past, and they tweak different elements and tweak percentages. This is how gold, silver alloys, platinum alloys have been created. It's a very time-consuming process. It's obviously extremely expensive, too. So you tweak something 1% here, 1% there. You add one other element. You got to run it through the tests. Doesn't work. Alloyed was one of the, if not the first. When I first met the owner, I was shocked, because they basically took what is done in the medical field. I'm going to compare it a little bit to DNA sequencing. So it's basically AI for metallurgy. And this was before we had ChatGPT on the market. This was already 6-7 years ago. So they were building alloys for the it's the Department of Health for the UK health market. Ball joints, things that go inside patients. So they were able to build out software where you could run through 1 million different alloy configurations with everything on the periodic table and narrow it down to 10 or 15 by putting in, here's where I want the hardness to be, here's where I want malleability to be. So it was totally game-changing to be able to use the entire periodic table versus what's been used, which pretty much for platinum, it's been some combination of either cobalt, copper, palladium, iridium, some gallium. Those have kind of been the ruthenium, the elements that have been tweaked all over the globe for 30 years. So what they were able to do was take us, what would have taken 2 or 3 years to narrow it down to a few different options to which then we could test with elements that you would never think would be in an alloy. So I was quite amazed when I first came on the project, and it was an exciting time to see how a new generation of developing metals and alloys, precious metals, but this company also does stuff for aerospace, defense industry, things of that nature. So it's really the first PT alloy that's a joy to work with, and it provides consumers with enhanced beauty and durability. Now, over the decades, there has been platinum alloys that are created, some that are extremely hard, some that are great for machining. I mean, a company, when I used to be part of Stephen Kretschmer, our tension set rings, that metal, that platinum alloy was extremely hard. It was great for tension setting, but you couldn't do anything else with it. You couldn't set prongs with it. You couldn't move it. So, as I said, there's been alloys that have been created. Johnson Matthey had some, which solved some of the issues. But was there ever anything that solved all of the issues? And there had not been. So this was the first alloy to really eliminate trade-offs between manufacturers, consumers, give the benefit to everybody. Here's some of the general facts that we have laid out. So it's about 4 times less porosity than your standard platinum alloys. A lot of that is due to the melting temp. It's got a very low melting temperature. So with platinum, the lower the melting temperature, the lower the gas porosity that you have in the casting process. It can lead to about 4 times higher production. It's 40% harder. It has a serious reduction in tool wear. And it enables potential skills and tools transfers from white gold. So that's important because we have a lack of jewelers in the US market. We actually have a lack of jewelers in every market that I travel to. I just landed from India yesterday. Even somewhere like that you would think with the 1.5 or 6 billion people, they have an endless amount of people in these facilities, and they don't. They have a hard time even recruiting at that level. Now, it's all to scale compared to, I would say, US, but I've spent quite a bit of time at Stoller, being one of the biggest players in the US, and we definitely have a hard time with the next generation coming on to become jewelers. And it's expensive for people even at GIA studying to work with gold, work with platinum. They tend to work with silver and copper during their studies there. So this enables someone who works in gold to be able to easily convert over to work in platinum. It's a 950. It does have ruthenium in it. The rest is proprietary, lower melting temp, very high fluidity. Machining, it's 3 to 4 times faster feed and speed rates. It's very precise, crisp cutting, drilling, and milling. Polishing, it's about 40% faster to polish Inoveo compared to your standard platinum alloys. It's got a lower rejection rate. Setting time is quicker. A lot of that is due to the drilling. Your tools don't wear out with Inoveo like they do your standard platinum alloys. It's brighter, wider, it adds additional security for the gemstones and increased wear resistance and durability. And you saw previously how platinum already compares to white gold, and then I'll show you here shortly how Inoveo compares to PT Ru. Here's a little bit of data, additional data. So for drilling test, it was okay, let's use the 4 major setting burrs that you're going to use. How long does it take for a burr to wear out? In Inoveo, we used PT Cobalt, actually, in this particular one. Ball burr was not a huge difference, but you get into the 45-degree burr, which is probably the most popular for your pave. 5 minutes it took and this was drilling repeatedly. So you got 5 minutes out of a burr, you get about 1:58 out of a burr in PT Cobalt. Drill bit, you can see, and then the 90-degree for your center stones. So quite significant. And anyone in here who's a jeweler, I mean, the cost of burrs has just skyrocketed. It's astonishing to me, where I remember it wasn't even that long ago, a 6-pack was $8 or $9. Now they're $20 for the steel, $40 for the carbide. So all of that adds up. Density. So the density of Inoveo is lower than your standard alloys, which means the cost is a little bit less. So you're using less overall material to make the same product. Color data. So this is something people want to know. How white is it? What is the L value when it's polished? We've ran these tests. This is just one data batch. We actually just had full certification from the Birmingham Assay Office. If anyone's aware, Birmingham Assay Office is the global leader in basically testing metals for everyone on every continent. They probably have the largest database of alloys that I'm aware of. But as you can see, so PT Ru is the whitest of the white. So that is the top of the food chain. Tends to be about 87. You can see PTIR, PT Cobalt, a little bit down. The important thing is Inoveo is right in line with those. So you get a very, very bright, crisp finish. Now I will say, and it's hard to capture on video, but when you're looking at a polished Inoveo ring versus even PT Ru, or I just got back from India, they use a lot of PT copper, PT palladium copper down there. You get a mirror finish to where you can perfectly see your reflection in the ring of Inoveo, where with your standard platinums, it tends to be, even though it's very bright, it tends to be slightly fuzzy. You get like a slight haze. And that's something you don't get with a Inoveo. So, and comparing it to your 18K, 14K whites, rhodium plated. So as you can see, it's on par. So for, a lot of this is for the end consumer. You know, that consumer who wants the chrome bumper. What does it look like? Does it stay bright? So this is one of the things, this is why it polishes quicker. This is why it drills better. You can see the hardness. It's 193 as cast. Your standard PT Ru is about 135, PTIR 80 to 90, cobalt, copper alloys, palladium Ru, palladium copper. There's a lot of that material coming into the US market because a lot of that is produced in India now for export into the US market for a lot of the big site holders. A lot of stuff you see coming through Signet, Blue Nile online. A lot of that stuff is actually not PT Ru. A lot of it's PT palladium copper, PT palladium Ru. So this gives Inoveo a huge, huge advantage in terms of hardness. But as you can see, it's not so hard. It's up there with your white gold. So you're getting all the benefits you get with platinum in terms of its malleability, security of the gemstones, but it's a harder product. So it doesn't get the dents and dings and scratches that you typically get with your standard platinum alloys in the marketplace. Some tensile strength data. I've got a couple slides on this, just converted PSI or MPa. As you can see, you would think for being harder, it must be more brittle. It must not have the strength. It actually has quite a bit. Now, it doesn't have quite the elongation you would get, so that would be a small sacrifice on this. And a lot of that is because of how much it work hardens. So going back to the hardness, I will say as extruded, so for the companies who are doing CNC of wedding bands, when you go through tube extrusion or ring blank extrusion, you can get Inoveo up to about 320 to 330 Vickers. So that's why when you're running it on CNC, it cuts like white gold. And I've got a few additional slides, so we can show that to you. And this is just broken down different MPAs, so just to show a little bit of the strength. So here is some additional testing that has been done. So this is this band over here. So this is extruded platinum ruthenium. This is a 90-minute CNC time to take it from ring blank to milling, drilling operations. It's about 90-minute run time. In Inoveo, we're running this 27 minutes. That's on par with what white gold roughly is. So some of the things, the wire drawing, we were getting about 20 to 30% greater efficiency drawing down wire. Now, I always preface this with, this is going to be on a little bit more of larger production scale. So if you're just in the shop and you're pulling down a few inches of wire, you know, you're not going to notice a huge difference. But large scale production that we're pulling down hundreds of yards at a time, it's quite significant. You don't get any fraying on the Inoveo wire. You don't get any ripples. It comes off very bright as you're pulling it down. Blanking, slitting operations. I've got a slide on that one more ahead, so we'll jump to that shortly. Part forming, so die striking. I spent a lot of time at Stoller while they were testing this. I was shocked how large Stoller's die striking capabilities are. Tens of thousands of die striking plates. So we put it through its paces there, and we were quite shocked. Even the Stoller team was shocked how well all the die striking. You know, we did have to get it annealed properly, but it had a very clean edge break. And so what that means is parts that come from Stoller, when they start manufacturing all their die striking in Inoveo, very crisp edges. So for the jeweler out there, they can solder things together, very little cleanup. Versus your standard platinum alloys, you end up with like this edge roll. Requires a lot of cleanup. Machining I already went through. I mean, we were 2 to 3 times quicker, so about 50% savings in cutting tool costs. You know, in the U.S. market, it used to be only the big players did a lot of CNC, but I know even a lot of smaller wholesalers and smaller manufacturers have CNCs in their shop now. You know, so and CNC tooling is extremely expensive. Just a couple quick things. So typically when you're machining platinum in general, you know, you get chattered edge. So it requires more cleanup, and that's running at a lower speed feed rate. When, you know, Inoveo is extremely crisp right out the gate. So it's a nice benefit to have. This was large-scale jump ring cutting. So cutting 2,500 of them at a time. So typically what you get with extruded, drawn down wire PT-RU, which, you know, as extruded is about 220. It's pretty hard. But when you're cutting it, and, you know, you end up with this. So this is what the jewelers end up with when they order product. And, you know, you have to solder that together. You need it flush. So you got to work on the file. You got to try and clean it up. It's a lot of work. As you can see, when we were cutting with Inoveo, it cut right through. We got about 2 to 3 times the blade life with the carbide saw. So that was benefits on a large scale, but even a, you know, jeweler with their saw doing fabrication, something like that, they would notice some of these benefits. So if you recall back, we had the wear resistance tests. So we ran Inoveo again against gold and against PT-RU. PT-RU was the top in that FEM study. And so as you can see, Inoveo is well below even PT-RU. We have some additional charts on this. I'm happy to send them over if somebody wants to see the longer tests on this. But this is what translates to the end consumer. Platinum already is the most durable and most secure of the metals, and to have Inoveo outperforming PT-RU on that scale just goes to show some of the great benefits to the end consumer. So their ring is going to stay much more like a chrome bumper for a long time. Right now, Stoller is the U.S. distribution for Inoveo, but it's I've been running around the globe. We are testing it in Europe, India, Japan. So I expect it to be available in various other markets shortly. So it takes time. A lot of companies, even large-scale companies, you know, again, there has been very little platinum development. So even tweaking large-scale production takes time at these factories, working with something that's that much harder. That's the end of the presentation. So I'm happy to take any questions anybody has.
Questions for Josh? Yes, over there.
Hi. In Inoveo die-strip platinum pin, are there any differences when soldering to, let's say, a new shank or an older shank that's just platinum or platinum iridium?
No, there's actually no differences, and that was some of the tests that I was very adamant. I said, we have got to be able to solder it to PT Cobalt, PT-RU. I want off-the-shelf solders tested from United, from Stoller. It just can't be a new alloy that then it has to be a brand new solder and a brand new laser wire, because I know, you know, being third generation, I know how it is on the production floor at the retail level. You have to be able to combine these things. So we had no problems. We ran small-scale testing. I had Stoller run large-scale testing. So in that aspect, the color matched up. You got it polished. The only thing I would say, and this really wouldn't be the case for a head so much, but okay, if you have to size a ring, right, and put in a new, like, let's say it needs to size up considerably, 3-4 sizes, something like that. The only thing you would have to be a little careful on is after, you know, during cleanup, because it is harder. So it's not going to wear when you're, you know, going through the sanding, especially if you do, like, you know, let's say a laser sizing and you really build it out. So you got to be careful on that edge that you're not, let's say, too aggressive on your PT rue, end up with a low spot. But other than that, matched up perfectly. We had no problems with that, knowing that that would be the case out there, because obviously there's a lot of platinums floating around in the market. And look, people are upgrading. They need a new head. They want, something new. They broke it, whatever the case is.
Also, do you have a list of casters that are using Inoveo?
I can get that for you. So let me get your info after, and I'm happy to get you that information.
Yes, here in the front.
Oh.
Yeah, guy right here. Go. Hello.
So, you were saying that it's 95%. Are there any of the elements that are going into it, elements we've never really heard of?
It's a good question. Yeah, no.
Things we've never even heard of.
No, you will have heard of them. I will say that. You will have heard of them. They're not so far on that periodic table that you're like, oh, wow, that's, I got to Google that one. So you will have heard of them. You just never would have thought they would have been able to add, a positive effect on a platinum alloy. And, it's interesting, a question that's come up quite a bit as I've been traveling around the globe is, okay, are these elements, can they harm the body? Can they harm the skin? Are they, because, there's concerns with that stuff. And, obviously when you get into, CIBJO and some of the global organizations, RJC, things of that nature, we have to be very careful on that. So this is why we actually had additional third-party testing done at the Birmingham assay office, because I called up anyone who knows anybody there at DePaul. He's kind of world famous for kind of being the guru of metallurgy testing. So we had it run through its paces. Every type of release, contamination releases, can it affect anything? And it got the Anchor Cert Pro certification, which is the top that you can get. I don't think it's as common here in the U.S., to be honest, but I will tell you the big companies in the U.S., they require these things. They just don't put them forth to the public. So now you will have heard of the elements, and none of them will affect anything. It's still hypoallergenic, which is, important. It would be a shame to build a new platinum alloy that then is not hypoallergenic.
Renee, did you have a question?
Yeah, does Stoller have all of this information on their website?
Yes, they do, actually. If you just go to stoller.com, just type in Inoveo in the search thing, they've got a bunch of information.
You can see some of those charts and everything.
I don't know how much of the charts they have, but they do have, I'll get your info. I'm happy to send some stuff over. PGI sends out a lot of this stuff as well. Stoller has some stuff up, but some of it's more is once you contact them, then they'll share some additional stuff. But I'll get your info, and I'm happy to get you additional data points.
Harold?
Does this Stoller sell just casting grain in this metal, or does it sell wire, rod?
Currently, they started with casting grain. They'll be launching the wire and rod shortly, and then I'll be adapting it to some of their in-house products. I think a little later this year. Stoller being such a giant, things do not transition very quick there. It's a little bit less on the production end, as it more is on just the transition of the software. And, because they offer something like 12 million products in total. It's like staggering. Last year I was there every month for a year, 1 week a month for a year, working on testing. So, but casting grain is available, and the wire and sheet is coming online very soon.
How does the price of casting grain compare to 18K gold?
I believe it's below 18K at this point. So there is a very small premium, so it's just a tad higher, a point or two, than like platinum ruthenium from them. But as of now, cost per gram of PT 950 is below 18K. And we're not that far off from approaching 14K, actually, at this point. So, the gold market, I guess if you own a lot of gold, it's great because the investments keep going up, but we all know it's tough. It's tough moving forward for the jewelry industry. So I'm seeing a lot of conversion on the white side back into platinum to offset 18K right now, and 14K is not too far off. But it's priced, I believe, below 18K per gram.
Josh, quick question.
Sure.
You've been talking a lot about casting, but what about hand fabrication? Is it better than 10% iridium? Is it going to be, is it going to last longer? Or ruthenium, the 95.5?
It will last longer. It does work harden quite rapidly in the first 20%. So there's a whole chart on annealing processes. So once you do that, it's not a problem, at all. So the hand fabrication, I do find with some people who hand fabricate platinum, because they've not even been using PT Ru, they've been using 95.5 PT iridium. Well, you don't even have to anneal that stuff. It just rolls and rolls and rolls, but it never really gets hard. So with Inoveo, on small scale, you can torch anneal. Larger scale, there's some oven annealing parameters. That is all available from Stoller. I tell you, last week I was in India at it's actually the largest gold manufacturing jewelry company in India. I think maybe the world. They do some staggering amount, like 10 tons of gold jewelry a month. It's astonishing. And their ovens for annealing were being occupied. So we had to go to torch annealing Inoveo kind of on a larger scale, and we were able to make it happen. So it's for the fabricator who's really good with platinum, and you know what you're looking at, not a problem at all. And it's one other interesting thing about Inoveo is it also is heat treatable. So once it's hard, there is a heat treatment protocol to make it even harder once finished, to raise it about another 20 Vickers. So if you need something that is extremely durable for the end consumer, even beyond, that is one benefit. Not a lot of people are heat treating, but it's available.
Great. Question here in the front? Did you?
Oh, I wanted to ask you about the end consumer. So over the years, clients have learned about, that platinum doesn't keep a strong polish, it looks dull. What is Stoller going to do in this country to help the retailer to convey this new alloy to their client? Do you have a brochure?
So this is, I would say, more of a Platinum Guild, what Platinum Guild has to do, more so than Stoller. Stoller is more of a distribution wing, and they will take kind of their marketing. There are some of that already available, but PGI, this is one of their, this is what they do. They're a marketing firm, and they promote platinum. So it'll be rolled out very shortly, because it's very important for the end consumer to be aware, and you need the retailers to be aware, and you need it in simple terms for the sales staff to be able to explain.
Okay, we have one last question right here, and then we'll send you to the back, and
Okay.
you can answer questions there.
Thank you.
Go ahead.
So regarding the sizing, does the patina form relatively similar? So like if you size a ring, are you going to get a patch that looks different over time?
It's gonna be much slower.
Okay.
Much slower.
Would the end result look similar, or?
It won't, actually. So if you were to combine, let's say, PT Ru and solder in a piece of Inoveo, let's say down at 6 o'clock, the PT Ru is going to patina, because it's going to get a little denting and dinging, and you don't really get much of that in the Inoveo. So there will be a little bit of a difference over time if you were to combine. So that would be something just to be kind of aware of. If I was repairing an older platinum ring, whatever the alloy is, I would probably try to stick with whatever that currently is. Now again, thinking ahead, you got consumers who just go crazy on their jewelry. So there could be a need to stick an Inoveo on the bottom half of the shank just because they're destroying it, you know, lifting weights, rock climbing, yet doing nothing.
Thank you very, very much, Josh.
Thank you, everybody.